So in our previous class, we were discussing about a surface integral along a closed circular line like this. Along a closed circular line. So this was kind of our C. Okay. So along the edges of this, along the curve C, we were evaluated here the line integral. But that curve C now define or construct a surface. The surface is a construct portion, right? Defines a surface like such a surface a construct portion. Okay. Now our target in here is to, if I denoted this surface by sigma, we denoted this surface by sigma. This surface we denoted by sigma. Okay. So our objective in here is to find if this is a surface which is denoted by sigma, and this surface has a very uh, small thickness, and that's why we call it the laminar surface. We call it laminar surface. Now, if someone would like to know what is the mass of this laminar surface, you need to do a mass bear করতে চাও, mass বের করতে হবে. You need to calculate the density into rho into the volume will be applicable for three-dimensional object, but since laminar surface is a two-dimensional object, so here mass can be calculated by density into area, right? Okay, here by density into area. So one thing is very important in here. Now, if you, the question is how to find out the area of this laminar surface, right? So what we did is kind of we look for its differential area, which is dA, right? Now, if density is constant, so then that is one thing. If density is not constant, that means along this laminar surface, some part has high density, some part has low density, right? So then we need to rewrite this one as function of x, y. Okay. And doing this, we can have the knowledge about the differential, the mass of the differential element. That means এখানে যে এলিমেন্ট আছে এই এলিমেন্টের ম্যাসটা আমরা বের করতে পারবো, স্মল এলিমেন্টের ম্যাস বের করতে পারবো, right? If I want to calculate the total mass, that should be integration of dm. In other words integration of dm along what? Dm along the whole surface, sigma f of x y d a. You can write down here basically ds better compared to dA, because dA we differential area for our uh, for any space in xy plane. So that's why it's better to change the notation from dA to ds. Yes. So ds is what? Ds is the differential area of this small surface element, and if we take the integration along this surface of f of x dy, ds will be able to get the total mass of this laminar surface. Okay, so here we call it the surface integral because we are integrating over the whole surface. Previously আমরা বলেছিলাম along the line, সেই জন্য এটা ছিল লাইন ইন্টিগ্রাল, along a line, আর এখন আমরা বলছি over the whole surface. Okay, sigma, that's why we call it the surface integral. Okay, another thing which is surface is a two-dimensional object, right? So here single integration is not appropriate. এখানে আমাদের basically single integration would be appropriate if the object is one dimensional, but the surface is a two-dimensional object, so এখানে আমাদের double integration apply করতে হবে. We have to apply here double integration. Okay, any question here up to now?
স্যার আবার একটু রিপিট করবেন?
Which part? মানে ডাবল ইন্টিগ্রেশনের কনসেপ্টটা নাকি সারফেস ইন্টিগ্রাল?
জি স্যার, ডাবল ইন্টিগ্রেশনটা
ডাবল ইন্টিগ্রেশনটা আমরা এখানে দেখো আমরা বেসিক্যালি ডিসকাশন করার সময় এখানে দিয়েছি সিঙ্গেল ইন্টিগ্রেশন, বাট দ্যাট ইজ নট অ্যাপ্রোপ্রিয়েট হিয়ার. ওয়াই? বিকজ সিঙ্গেল ইন্টিগ্রেশন উড বি অ্যাপ্রোপ্রিয়েট ইফ দ্য অবজেক্ট ইজ ওয়ান ডাইমেনশনাল. যেমন আমাদের লাইন ইন্টিগ্রালের লাইনটা ছিল ওয়ান ডাইমেনশনাল অবজেক্ট, দ্যাটস ওয়াই উই হ্যাড টু অ্যাপ্লাই এ সিঙ্গেল ইন্টিগ্রাল অপারেটর. বাট সারফেস ইজ নট এন ওয়ান ডাইমেনশনাল অবজেক্ট, তাই না? ইটস এ টু ডাইমেনশনাল অবজেক্ট, কারণ তুমি তার এরিয়া বের করতে হবে। তাকে যদি তুমি মেজার করতে চাও এরিয়া দিয়ে মেজার করতে হবে, নট এ লেংথ। লাইনকে যেমন লেংথ দিয়ে মেজার করতে হয়, যেটা সিঙ্গেল ডাইমেনশনাল অবজেক্ট, রাইট? কিন্তু সারফেসকে আমরা এরিয়া দিয়ে মেজার করতে হয়। সো এরিয়া দিয়ে যখন মেজার করতে হয়, সো ইউনিট this is because this is a two-dimensional object, right? That's why we have to here apply double integral operator. We must have to apply here double integral operator. Does it make sense?
Yes sir.
কেমন? এখন অবজেক্টটা যদি তোমার থ্রি ডাইমেনশনাল স্পেস বা থ্রি ডাইমেনশনাল অবজেক্ট হতো, তাহলে এখানে ট্রিপল ইন্টিগ্রাল অ্যাপ্লাই করতে হতো, লাইক আমরা যেরকম ভলিউম ইন্টিগ্রাল বের করেছিলাম এর আগে, ঠিক আছে? নাও দ্য ইম্পর্টেন্ট পার্ট, যেমন আমরা লাইন ইন্টিগ্রালের সময় ডিএস টাকে আমরা স্কয়ার রুট ডিএক্স বাই ডিটি হোল স্কয়ার ডিএ বাই ডিটি হোল স্কয়ার এভাবে করেছি, তাই না? এখন এই সারফেস ইন্টিগ্রালের ডিএস টাকে আমরা কিভাবে এখানে ইমপ্লিমেন্ট করব? সো that is another question. On the other hand, আমরা এখানে ফাংশন অফ এক্স ওয়াই করেছি, এটাকে এই সারফেসটাকে আমরা বেসিক্যালি ফাংশন অফ এক্স ওয়াই জেড যদি করি, ইটস এ লেমিনার সারফেস, যেমন তোমার এক্স স্কয়ার প্লাস ওয়াই স্কয়ার প্লাস জেড স্কয়ার ইকুয়ালস টু এ স্কয়ার. ইটস এ সারফেস অফ এ স্ফেরিক্যাল সারফেস. ওকে, সো আমরা যদি একটা স্ফেরিক্যাল সারফেসকে এখানে ডিনোট করতে চাই, তাহলে ফাংশন অফ এক্স ওয়াই দিয়ে আমাদের হবে না। মানে থ্রি ডাইমেনশনাল স্পেস যদি একটা সারফেসকে ডিনোট করতে চাই, তাহলে ফাংশন অফ এক্স ওয়াই দিয়ে এটাকে ডিনোট করলে আমাদের হবে না। we need to denote it by, we need a little correction. এটাকে আমাদের এখানে এটাকে ফাংশন অফ এক্স ওয়াই জেড দিয়ে চয়েস করতে হবে। ফাংশন অফ এক্স ওয়াই জেড ds x y like this. Whereas z is a function of, or I mean z is also a function of x and y. If we have such a scenarios for the surface function of x y z, right, then this ds now can be written by ds then can be written by, this is one way of writing ds, but another process হচ্ছে যে if z is also a function of x y, then ds can be obtained by del z by del x whole square del z by del y whole square plus 1 into d, এভাবে ক্যালকুলেট করা যায়, ঠিক আছে? So and যখন আমরা এবার ক্যালকুলেট করবো ডিএ করবো, দেন sigma will be replaced by here by a surface area r, replaced by r. Okay. So what is R? Basically, R is the projection of this surface, laminar surface in the XY plane. So what is R? If I write down what is R, where R is the, let me explain, the R is the projection of the surface, the projection of the laminar surface sigma on the XY plane. Does it make sense to everyone? তোমার তো এটা সারফেস আছে, রাইট? এই সারফেসটাকে যদি আমরা এক্স ওয়াই প্লেনে প্রজেক্ট করি, তাহলে যে এরিয়াটুকু পাবো, যে রিজনটুকু পাবো, সেটা হচ্ছে আমাদের আর, and over that region we have to complete this double integration. Now this double integration is the same as this surface integral. Okay, দেখো সবাই ফলো করতে পারছো কিনা the discussion. One more thing should be mentioned in here. DS can be also obtainable by writing here norm of del r by del u times del r by del v, where r is what? R is kind of the vectorial information of this laminar surface. I mean x I hat plus y j hat, that's it, k hat. Okay, but both x and y, where x is a function of, let's say, uv, y is a function of also uv, parametric representation, z is also a function of u. So this is another way of writing ds. I want to make it a color. This is another form of writing ds. But most likely we follow this formula. A formula আমরা most likely follow করি. Because most of the cases surface definition থাকে z is a function of xy, a format. Now we shall move on to exercise. Okay. So here each and for every problem, we are asked to find out, evaluate the surface integral ds. This integral needs to evaluate it, and how one problem is different from the other one is kind of uh, the function of xyz surface has been changed, and surfaceর definition change হয়েছে and function of xyz has been changed. So changing these two information, then the problem has been varied from one to another. Let us now look at the problem number one. We need to find out the surface integral, this surface integral. Find out the surface integral where sigma is the portion of the cone this between the planes z equals to 1 and z equals to 2. So how it is, we need to draw the graph a little amount, little bit, like if we want to follow this formulation, so we need this information del z by del x, del z by del y. So fortunately here z is given explicitly. So this is exercise 15.5, problem number one. So what do we need to calculate here? Surface integral function of x, y, z ds. Where how sigma is defined here, where f of x, y, z is given by z square, and the sigma over which we need to calculate, we need to evaluate this surface integral. Sigma is given by z equals to square over of x square plus y square, z equals to 1, z equals to 2. This indicates basically such a cone, such a cone suppose this is a cone, right? This cone is cut down by z equals to 1 and z equals to 2. If we do so, this part will be going out, this part will be also going out, right? So finally what do you have is so a portion to the left one. So over this surface, we need to calculate the surface integral. Okay. Now z is given by square over x square plus y square, z equals to 1, z equals to 2. Okay. So you see here there is a circular part here, right? So if we take its position on the xy plane, xy plane যদি আমরা এটার position নেই, right? What do you observe? লোয়ার যে পার্টটুকু আছে, লোয়ার পার্টটুকু তুমি এখানে একটা স্মল সার্কেল পাবে, আপার পার্টটুকুর জন্য if I consider different color, লোয়ার পার্টটুকুর জন্য তুমি পাবে এখানে একটা স্মল সার্কেল is corresponding to this position নিলে, আর আপার পার্টটা position নিলে you'll consider here a big circle. Okay. Come on. So now ds, if we calculate ds here, ds will be here square root over of del z by del x square plus del z by del y square plus 1 into dA. So del z by del x would be here So del z by del x square, which is x square by x square plus y square over x square plus y square plus 1 into dx. And that will be 1 plus 1 plus 2, 2 into. So therefore, this surface integral then can be reduced into f of x y z is z square. Z square is basically x square plus y square according to this combination. Square root of 2 dA r. So what is r here? R is basically this annulus region হচ্ছে আমাদের এখানে এটা হচ্ছে আমাদের। If we transform it into polar coordinates, this will be r square or dr d theta. R will be ranging from here 1 to 2. Theta will be ranging from here 0 to. So let me explain you how we are getting this information. That indicates if z equals to 1, that indicates x square plus y square equals to z square 1 square. If z equals to 2, then it indicates x square plus y square equals to 2 square. So this indicates r equals to 1, this indicates r equals to 2. Therefore, the ranges of r from 1 to 2, but since this is a circle, annulus region, theta is from 0 to 2. So r is from 0 to 2, theta is from 0 to 2. Therefore, square root of 2, r square r cube, r to the power 4 by 4, 0 to 2, theta integration theta, 0 to 2. The result is coming here is square 2, 16, 4, 2 pi. 8 is square root 2 pi. So that is our answer. Any question here? If no questions, then we can move on to our another problem. Next number number 2, function of x y z equals to x y, or sigma is the portion of the plane x plus y plus z equals to 1 lying in the first octet. Okay. That's for number 2. So here we need to calculate again such a surface integral where f of x, y, z is given by xy and sigma is given by a portion of the plane x plus y plus z equals to 1, where first octant means x, y, z all should be greater than or equals to 0. Cool. Now here you can write down z equals to 1 minus x minus y. From there, ds can be written by square root of del z by del x square, del z by del y square plus 1. We'll have it here 1 plus 1 plus 1. We should here write down dA. It's coming out square root 3 dA. Now যদি আমরা area বের করি, okay, so let me now write down, transform the problem here. XYZ is tying up, is coming up xy. ds will be coming up square root 3 dA. Now the question is what will be r. So r will be in the xy plane. So when in the xy plane z equals to 0. If z equal to 0, then x plus y turns out 1, and which represent in the xy plane this straight line, right? For this is when y equals to 1 minus x, y equals to 0, x equal to 0 to 1. Taking this square root, so x, y, dy, dx, y is 0 to 1 minus x, and x is there 0 to 1. Completing this integration, so here is our answer. Okay, everyone please have a look into this calculation. If you find any error or if you have any questions, you can ask me.
স্যার থার্ড টার্মটা এক্স কিউব হবে না?
Any question here? So are you get any difficulties following this solution process? Okay, if you have no issues, then we'll move on for another problem. Next, number 4 here. Number four is given what? F of x, y, z is x square plus y square into z, and sigma is the portion of the sphere base above the plane z equals to 1. So that indicates what? Again, number 4, let us write down the formula. Sigma, function of x, y, z, ds. Uh, f of x, y, z was given in the question by x square plus y square into z, and sigma is given by this, and z should be greater than or equals to 1. Above the plane z equals to 1, that means z greater than or equals to 1. That indicates, suppose if I have here x-axis, y-axis, z-axis, and if I draw a sphere like this, okay. So and this is a sphere x square plus y square plus z square equals to 4. From here you can write down z equals to plus minus square root of 4 minus x square minus y square. This is what you can write. But z greater than or equals to 1. Since z greater than or equals to 1, that means no negative sign will be applicable in here. Only the positive sign will be applicable, right? So only the positive sign. Now z equals to 1. Z equals to 1. Let's say z equals to 1 is here. Z equals to 1 point cut code is z equals to 1, right? So here you will get a circle in the cross section. A সার্কেলটাকে যদি এখন আমরা এক্স প্লেনে প্লট করি, that will represent what? তোমার হচ্ছে x square plus y square plus z. Z equals to 1 যদি z equals to 1 here. 1 equals to 4. So it turns out x square plus y square equals to 4 minus 1, 3 root 3 square. So I'll then get here a circle, this one, in the xy plane, which is corresponding to the cross section of the sphere and the z equals to 1 plane, and that represents this circle where r will be 0 to square root 3. So here del z by del x square, del z by del y square plus 1 dA. Del z 1 by 2 minus 2 to 2 out, so x square by 4 minus x square minus y square plus y square by 4 minus x square minus y square plus 1 into dA. We can come up with plus 4 by 4 minus x square minus y square to dA. That will be 2 by square root of 4 minus x square minus y square to dA. So replacing all these things in here, this will be r. What will be r? R is now this part. This circle is now r. If of x, y, z is, we can write down here 2 by z dA. This is x square plus y square into z, and ds will be this value 2 by z into dA. This z is out 2. Now r আমরা একটু একটা লাইন এখানে বেশি করছি so that you can follow it. So since these are is the polar coordinate x square plus y square, we can replace it r square r dr d theta. R is from 0 to square root 3 and theta is from 0 to 2 pi. Therefore 2 into r cube r to the power 4 by 4 0 to square root 3 and theta 0 to 2 pi. Square root 3 to the power 4 means 3 square 9. 9 by 4 9 by 2 into 2 pi. The result is coming up 9 pi. That's why follow করতে পারছো solution persistent. Is that okay, everyone? Let us solve another one if you have no questions. For number 5, we're going to solve then number 6 here. Number 5. Number 5 has a little difference compared to the other problems. We see what differences we can observe in here for number 5. So for number 5, we are given here the function of x, y, z, dx, where f of x, y, z is given by x minus y minus z, and sigma is given by x plus y equals to 1, and first octant between z 0 to 1. Okay, so from this information, one thing we observe is that limit of z is given. If the limit of z is given, so then the formulation that we have here, uh, just look at here. So if the limit z is given, so we need to follow a formula like this, where um, ds should be written in terms of x and z. Okay, মানে z and y অথবা z and x. So in this case, আমরা z and y অথবা z and x যেটা দিয়েই করি, that would be workable. So since এখানে একটা formula আমরা এখানে mention করে রেখেছি, which is now we cannot, from this equation we cannot write down z is a function of xy. Rather, we can write down y is a function of x and z, or x is a function of y and z. Okay, so under these assumptions, let me write down y equals to 1 minus x, so that ds can be written here by dy by dx whole square, del y by del y, and in that case this will be 1 plus del z by del y. Del z so it should be y is a function of x and z. Yes, 1 plus del y by del z square, something like this, into dA. So 1 is coming because of del y by del y square. So here del y by del x is minus 1, minus 1 square is 1. This is 0 plus 1 dA. We can come up with square root of 2 dA only. And since in the first octant, it is said in the first octant means x, y should be also greater than or 0. So that means, if I write it down, function of xyz is x minus y. Y means 1 minus x minus 1 plus x minus z square root of 2 dA. Here is r. If I consider r should be in the xz plane, xz plane z এর value হচ্ছে আমাদের this is 2x minus 1 minus z square root of 2 dz dx. Z is from 0 to 1. What will the limit for x? If y equal to 0, x will be 1 maximum. X will be here. I mean, x plus y equals to 1 graph that is number drawing for 0 to 1, 0 to 1. So x will be 0 to 1 only. X will be 0 to. So square root of 2, 0 to 1. Z different number complete 2xz minus z minus z square by 2. 0 to 1 dx 0 to 1 2x minus 1 2x minus 1 minus 1 over 2 dx. That is 0 to 1 2x minus 3 by 2 dx. Integration complete করলে this will be 2x হচ্ছে x square by 2 minus 3 by 2x 0 to 1 result coming out with 1 minus 3 by 2. And the result is minus root 2 into 1 over 2. So we can add minus 1 by. So that's our answer. Okay. So এখানে আমরা এটাকে y is a function of x এর choice করেছি. We could have changed it to x is a function of y and z. Okay. Look at the solution process one more time. If you have any question, you can ask me. Meanwhile, let me take your attendance.
স্যার আমরা কি এক্সের প্লেন থেকে এক্স এর ভ্যালুটা নিছি?
এক্সাক্ট প্লেন জেড এক্সাক্ট প্লেন থেকে এক্স এর ভ্যালুটা নিয়েছে, রাইট? যদি আমরা এখানে x plus y equals to 1 এটা এখানে ড্রয়িং করেছি, ড্রয়িং করে আমরা x এর ভ্যালুটা নিয়ে আসছি, মানে হাউ মাচ x ইজ ভ্যারি, x ভ্যারি করবে 0 থেকে 1 পর্যন্ত, ঠিক আছে? x plus y equal to 1, this equation in the xy plane, here y is varying from 0 to 1 minus x, x is varying from 0 to 1, but we have taken only this value because we need only the limit for dz and dx. So z limit has been obtained from here 0 to 1, our x limit is obtained from here 0 to 1. ঠিক আছে? Make sense?
Yes, sir.
This one is a little tricky because here z is not a function of xy.